I'm Rajat. I'm SRE at Block, and welcome to my talk, Automation with Secure and Scalable SSH. Before talking about scalable and secure SSH and automation, let's look into scalable and secure SSH. How many of you still use SSH? Okay, almost all the audience, because it's very cloud native and people use SSM and everything, but SSH is still a standard way to access your systems. And if I talk specifically about OpenSSH, it's been very popular in the market, but we don't use full of its feature, or we don't use all its potential. So moving on, how can we achieve scalable and secure SSH? Using SSH certificates. What that means, we will use SSH certificates to SSH into the machines, not with the SSH keys. And moving on, why we need SSH certificates is first to make it scalable. Scalable means if number of employees are growing in the company, it means they need, like you have 100 developers, and next year the company decide to make 100%, increase the 100% of its workforce. And then now you have to manage the number of users for it will keep on growing, and then you have to manage number of users as they increase. So we have to make it scalable. Secure, which means we want to make it secure, restrict the control, who access what in the systems, and we do not want to grant unnecessary or unauthorized access to the systems. Last, let's talk about applications. Once we have secure and scalable SSH, what about its application? I will talk about Ansible in itself, but there are many other applications as well where you can use it. So, yeah, if I talk about Linux distributions, there are many accounts, like for example, root, and some other accounts, like for Ubuntu, there is a Ubuntu default user. In Amazon, there are EC2 users. So there are default users. They are being created with passwords into the system. And when the company grows, we use LDAP. The company starts to use LDAP or some sort of thing to access the systems, to grant access to those systems, which means it is a single point of failure. We talk about removing the single point of failure, but LDAP or same kind of systems are single point of failure, and we want to get rid of them. For example, if you're logged out of your systems or LDAP is down and there is an incident, you cannot access your machines, and this is a nightmare nobody wants to handle. Now what we do? Let's go back to old traditional way, put everyone's public key into the system and grant access. No, that's not as good. This solution is really not scalable, because you have to manage the number of users and their public keys. And for example, developers keep on changing their public keys or SSH key pair if they are too much secure, if they want to be too much secure. So it's a nightmare to manage the public keys, even on any systems who use SSH-based authentication. What we use signed certificates. Signed certificates provide single point of trust, not failure, which means whatever is coming from the signing authority, it is trusted and it is allowed in our system. And it also removes any third-party infrastructure, which is good, because you do not want to manage multiple systems or multiple third-party systems just for SSH or access. Now talk about what SSH certificates are. SSH certificates are signed public keys using the certificate authority. The SSH certificates contain the CA fingerprint, the certificate authority's fingerprint, public keys fingerprint, and the validity of the certificate. What that means, the certificates are valid for a certain point of time. They are not indefinite valid. The ID of the certificate, serial number, allowed principals, critical options, and extensions. I will talk about critical options and extension more, as well as principles. Now the question, how can I create certificates. So this is a simple command. You can try on your terminal to get your certificates. So for example, if I create certificate from this, something like this pops out. So if you see the certificate, it has the ID of the certificate, which means to whom this certificate belongs to, what is the serial number of that certificate, what is the validity. So you can see this is valid for a day. What are the allowed principals, extensions, and critical options as well. Now comes to the important part. We know there are SSH certificates. We know we can trust them and we can use them as a single point of trust, but how do we use it in our systems? How the authentication and authorization workflow works there? It's very simple. Configure your systems to trust the CA and everything it signs. It is a very simple concept which has been brought from HTTPS world and it has been put into the SSH world. Certificates provide single point of authentication and authorization using signature and principals, and authorization further can be controlled by extensions and critical options. So moving on, now if I talk about configuring systems to trust the CA and everything it signs. So here is a snippet you can find for SSD config. I'm trusting my public keys of my CA. If I want, I have option to revoke keys, and there are authorized principals file. I will show you more. Yeah. Now coming to extensions and security, they are the most critical part because here you can control explicit authorization of the certificates. For example, clear cleans out all the default permissions on the certificate, so it means there is no default permissions allowed. Force command can strictly tie the certificate to run specific commands on the server. They are not, you will not never get any full access. For example, if developer wants to get access of a list of running containers in a server, so you can grant the certificates specifically to run those commands. And my favorite ones, no agent forwarding, no port forwarding. This is the very nasty one people still use. And this you can also disable it. And also disable the sudo terminal. You can also disable the RC file execution as well as X11 apps. And very critical part, you can tie the certificates to run from a certain IP address. So for example, if I'm in UK, my IP changes. I'm not allowed to access my servers because that defeats the purpose of security. It is only allowed from a certain IP address. For example, if I'm connected to my VPN and then I have a certain IP, and then it is allowed to access those servers. So it means our certificates can do a lot more. Now we don't have to implement extra security, extra rules on firewall, extra rules on security groups, anything. So generating a certificate is very simple. I showed you, in an example, you can say I'm signing my certificate using a key with a ID Linux, principals is SRE, and the serial number is I'm with the date. And here the interesting part is I'm explicitly allowing certificate to run hello world echo. So if I use this certificate, it will only run this command only on the server with no agent and port forwarding. And also the source address, you can see the certificate is only allowed from this IPCIDR. How the certificate now looks like. It looks like the ID is Linux, serial number, when is the validity, critical part. If you can see the validity option, it's valid for 1 day. So our certificate is only valid for 1 day and it will expire after that. So it means it is not valid anymore after a day. You need to reissue another certificate. The certificate looks like this. You can see the validity, principals, critical options, and the source address. So it is only allowed from this IP, and the certificates can run only this command. And there are no extensions. So you can say, using this, we have disabled the port forwarding or any other extensions as well. Another part, so now we have a certificates, and how can we see what is the authentication logs on the server? How would I come to know who logged in when on my machine? So here you can see this is the auth log of the server, it will see for which user it logged in, from which IP it logged in, and what is the ID and serial number of the certificate, as well as you can get the fingerprints for both CA and public keys. So for example, we have certificates, we are granting everything, but what happens if I want to block certain certificates or certain keys from to allow our machines? So here you can see there is a revoked keys. I can add a SSH fingerprints or the public keys to the revoked key file, and the system will disable the access for them. Okay, so now talk about its deployment strategy. It's as I mentioned, user-based authentication is no good. It's not scalable. So we'll get rid of that option. And the nice option is role-based. In company, we don't talk about users, we talk about roles. There are roles, can be developers, SRE, release engineers, or QA, for example. And if we grant certificate based on the role, then everyone has the same access, same kind of access, and they will be expiring after a certain point in time. So we don't have to worry about it. To roll it out, we need to create CA first. To create a certificate authority, we create, for the security, we create certificate authority for each role. For example, for SRE, there is a different certificate authority which grants different kind of permissions. For developers, there is a different certificate authority, as well as we allow that CA to add desired extensions or permissions to the certificates, allow client and users to sign that certificates from those CA, because if I'm not able to get my certificate from that CA, the CA is of no use to me. And if you don't want to build tooling around CA, it's too much. HashiCorp Vault is free to use. It also provides free SSH CA certificates. On server side, we need to create a base image for those certain roles with allowed principles. We use, and we allow our SSH daemon configurations to have those principles for that users, and we roll that base image out for entire infrastructure. Yeah, and this is, by doing this, you are not creating users anymore, you are trusting your CA, and you can roll back your CA as well. So it becomes very neat. Coming to the applications, okay. Now we have a scalable and secure SSH. We know how we can achieve that and where we can use it. Before that, there is a key principle for that. Never use keys with indefinite validity, because that's dangerous for a longer period of time. So for example, if your keys are not expiring or you are not rotating, that's a security concern, and that should be avoided. And if I talk about Ansible, Ansible use SSH-based authentication, and how many of you use Ansible? Oh, that's great. A good audience. Okay. So how many of you use SSH keys which never expires for Ansible? Okay. So we have a couple of hands here as well. And what that means here, the keys, if the keys are never expiring, it means the automation, we are not controlling the access to our systems, which means if anyone can get hold of those Ansible SSH keys, they can exploit our system. To do that, first we set up our CA for Ansible and with its valid principles and extensions. We set up a validity, for example, 1 day is a very nice way, for Ansible. And on Ansible machine, we sign the certificates from the CA and add those into our configurations. So for example, we can control using Ansible CFG file to add those configurations, and on the server, we trust the CA. Oh, it's gone. What happened? Okay. Just a second. Yeah, okay. Yep, okay, so now, on the server side, we use On the systems, we add Ansible user with its valid principles and trust the public key on the system. That's how we can, that's only the setup. And by doing this, the Ansible can use your certificates, which are valid for a certain point of time, for example, 1 day. And they will be having certain principles. So it means not everyone can use those certificates. You can also restrict controls. So for example, if IP address of Ansible control machine is something, we can also tie that to that one. So for example, by doing that, those certificates are only valid, allowed from that specific IP address. Other applications can be GitHub access. We use public keys for GitHub access. We can also use certificate-based access. So if the users are coming in or leaving the organization, we will not have to manage those because they still have certificate-based access. Other login credentials, we can use those certificates for developers, SREs, and all other roles in the company. So no public keys. And we can also hook it to Tower or AWS as well. Okay, enough of it. Let's talk about demo. Okay. Is my screen visible to everyone? Yep. So you can see my folder here. It's my cert. Here are the certificates. So I can take this. Here are the certificates. For example, public key and private key of my CA. Here are the another certificates. So for example, if I do this, so okay. So this is the private key. Similarly, so for example, I have this another VM here. This is Linux, my VM. Okay. Okay. SSH. Oh man, it's hard to see. Like this. SSH config dot. So you can see I have allowed my certificates to have this public keys. So which means in my system I am trusting my public keys of my CA. Here you can see the revoke keys. If I look what's inside of them, there is nothing right now. And here it's the authorized principles. So if that's the interesting part. So if I look here, you can see there are different users for that machine. One is Ansible, one is for developer, one is me, and one is Sari, and one is root. And let's talk about Ansible. What Ansible has access to those. Ansible has allowed principle as automation. And for example, if I talk about developers had allowed principle as dev. Moving on to that, let's try to access our machines. Okay, so if I show you my generate dev cert file, so this is my certificate generation file to generate the certificates for the dev. So for example, the user is John Doe. He is a developer with the allowed principles of dev. As you can see the files, it's dev. User can only run Docker PS commands, and it is allowed from everywhere for now. So for example, when I generate those certificates, you can see the certificates is generated here. And if I inspect that certificate, no. So you can see the certificate belongs to John Doe with the serial number, and it is valid for a day. The allowed principles are dev, and the force command is Docker PS. The user can only run this command, and the source is from anywhere for now. Users, the allowed permissions are sudo terminal allocations and running the RC file. So let's try to SSH into the uh, dev machine. So when I'm SSH accessing the machine, it returns the command. It does not give me the shell access. It just returns the number of containers running in the machine. So by this, we can control the access or what commands certain users can run into the machine. Similarly, if I see the, okay, so if I see here my auth log, okay. So here you can see the accepted public key for developer user from this IP, and for user John Doe with serial number is this. This is the fingerprint for certificate. So by this, we can see who is logging in to the system and what is the serial number of that certificate. So from which certificate they logged in. In our case, I can also identify, in my case, for which date the certificate was issued as well. So coming to Ansible, okay. So if I'm trying to ping the machine from Ansible to my, just a second. Live demos are hard. Okay, it was correct before. Yeah, so you can say my Ansible cannot reach to the machine right now because I have not set up the public key access on the system for my Ansible user. If I generate the certificate for Ansible, and this is what exactly this does. So basically the identifier is Ansible, the allowed principles is automation here. And you can also see it has all the permissions, like, but with no agent or port forwarding or even not allowing X11 apps. And now let's see if I'm trying to ping my machine, it works now. So what we have seen here, we are not managing public keys for the user. We are not managing anything on the server. We just trusted the public key of our CA on the systems, and boom, it works. After one day, the certificate will not be valid anymore. So for example, if I delete the certificate as well and try again, it will work because, yeah, the process is still running. I have to kill that, but yeah.